Hello, this is Professor Kuehn and welcome back to my lectures on astronomy. Let's spend a few minutes talking about and reviewing the last chapter of Copernicus's Revolutions of the Heavenly Spheres. We're looking at Chapter 11 in a Student's Guide to the Great Physics texts. And you might remember in this chapter, what Copernicus is doing is he begins with a preface and a dedication to Pope Paul III. The next thing that he does is in his introduction, he talks about how astronomy is one of the liberal arts. He says it's the chief of the liberal arts and that it directs the mind toward contemplation of the divine creator of the world. But even though it is one of the liberal arts, it still has some practical benefits. And this is what he talks about on page 136. He says that astronomy also is practical in ordering the affairs of society. And he gives the example of calendar making, which is used to order the festivals, the months, the years, and so on, that keeps society ticking, so to speak. And then he gets into the bulk of the text. So this begins on page 137, where he starts in chapter 1 saying that the world itself is spherical. Now remember, the world, by that he means the universe. And here he's saying the world is spherical. So you're going to notice in the next few chapters that Copernicus is really just reiterating some of the things that Aristotle and Ptolemy had said before him. He's basically saying, I'm on board with a lot of these ancient ideas. So he says the world is spherical. He gives a number of reasons, for instance, that the sphere is the most important shape. It's the largest volume for a given surface area, and also it's kind of a common theme in nature. If you look at the sun or the moon, they look round, so circularity or globularity seems to be a theme in nature, so it would be sensible for the universe itself to be a globe or a sphere. Now, you may or may not agree with this kind of argumentation, but these certainly aren't unique arguments to Copernicus. There are ones that were used by Aristotle and Ptolemy, so clearly Copernicus has read his ancient cosmology. In chapter 2, Copernicus goes on to say that he believes the Earth is spherical too. So again, nothing new here. He's going to tick off a number of the reasons why he thinks that the Earth itself is a sphere. So for example, he mentions that if you walk toward northern latitudes, the North Star appears higher and higher in the sky. And conversely, if you walk farther to the south, the North Star appears lower and lower toward the horizon. And this would be sensible if the Earth was in the shape of a sphere. He gives a number of other ideas, and once again, he's just reiterating these ancient ideas, showing that he's on board with a lot of these things. The next chapter, chapter 3, I find this to be one of the more difficult chapters to understand, because here's what he's doing in this chapter. He says that land and water make up a single globe, the globe of the Earth. But what he seems to be arguing here is that the Earth is made of more earth or ground or land than it is of water. Now this might seem obvious to you. After all, you've seen in your 8th grade earth science books, you see pictures of the Earth where it's mostly rock and a little bit of water's over the top of the Earth. It's molten rock, like magma in the middle, but people are pretty sure that the Earth is made of mostly rock. Well, keep in mind that the deepest hole that's ever been drilled in the surface of the Earth only goes down about 10 kilometers. So we've literally only scratched the surface of the Earth. So those pictures you see in your earth science books, those are speculation. Nobody's ever been near the center of the Earth to know what it's made of. They're educated speculation based on earthquake data and so on, but it's speculation nonetheless. And apparently this kind of speculation was happening at the time of Copernicus as well. And you might think about it this way. People were exploring the surface of the Earth, and they noticed that there was a large amount of water over the entire surface of the Earth. In fact, most of the surface of the Earth seemed to be covered with water. So there seemed to have been a debate about whether there is more water or land that makes up the globe of the Earth. And this seems to be a reasonable concern. And what Copernicus is doing is he's saying, well, we know that rock sinks in water. We learned that from Aristotle, after all, or just by looking at the world around us. And so it makes sense if there was land underneath the water we see around us on the surface of the Earth. So that's the basis on which he is arguing that the Earth itself has more earth than water. Okay, let's go on to chapter 4. Chapter 4, this is called the movement of the celestial bodies. He says, is regular, circular, and everlasting, or else compounded of circular motion. So what he's saying here is that he's asking us to recall the work of, once again, Aristotle and Ptolemy, And they had claimed that the planets, the moon, and the sun are riding on these spheres that are themselves in circular motion around the Earth. That's in fact how they accounted for the motion of these heavenly bodies. What Copernicus is doing here is he's saying, I agree with this. I agree that one needs to appeal to the motion of these celestial spheres on which these objects are riding in order to account for their motion. But what he's going to be doing, we'll see in the next couple of chapters, is simply reorganizing these celestial spheres. He's going to put them in a different order, a different configuration, so as to make the sun at the center rather than the Earth. At the top of page 140, he gives some of the reasons why he thinks that one must retain the notion of these celestial spheres. He says, we must, however, confess that these movements, the motion of the sun, the moon, the planets, and so on, that these movements are circular or are composed of many circular movements, in that they maintain these irregularities in accordance with a constant law and with fixed periodic returns. And that could not take place if they were not circular. So what he's saying here is that when you see the sun rise and set each day, there's a periodic return. It's rising and setting, rising and setting, rising and setting, or the moon rising and setting, rising and setting. The only shape that can bring back what has already passed is a circular shape. So the circular shape is kind of a natural shape for bringing back things that have already happened in the past. That's what he's arguing, and he's in agreement with that. Now, there's one problem, and that is, he mentions here, this is hinted at in this sentence, and he develops this idea a bit more. He says the problem is that the planets, and in fact even the sun and the moon, but particularly the planets and the sun, appear to exhibit certain irregular movements. That is, they do not progress with a uniform speed through the zodiac. So recall, let me draw a picture here to remind you of what he's talking about here. So recall from the Ptolemaic picture. You've seen this picture drawn by me a number of times, but I'll draw it once again to refresh your memory. If we've got this celestial sphere here, and we have the Earth at the center of the celestial sphere, and the celestial sphere, according to this theory, once again, is rotating around the Earth one time per day. But remember also there's this tipped circle like this. That's the circle of the ecliptic. Actually, I'll make it wide so it reminds you that this is a band of the zodiac. Okay? And the zodiac, of course, is broken up into 12 constellations. I'll kind of indicate that with these lines here. And from the perspective of a person standing on the Earth, I'll color the Earth green here so you remember that's the Earth. I guess I could have made it blue. Okay. Remember, the idea is that from the perspective of the Earth, the sun will appear to be in front of one of these zodiac circles on a particular day, but that the sun migrates through the zodiac because it is itself riding on a sphere that's rotating around. So over the course of a year, the sun, from our perspective, migrates through the entire zodiac, right? So that's a progression through the zodiac, and this is why people believe that they're riding on spheres, because the sphere naturally brings things back to the position they had been a while ago. Okay, now remember, the sun progresses through the zodiac from our perspective once every 365 and a quarter approximately days, 365.224 or something like that. But here's the point that, this is all review so far, but here's the point that Copernicus is highlighting here. He says, even if you watch the sun progressing through the zodiac, if you measure it very carefully, you'll notice that the sun does not move at the same speed through the zodiac over the entire year. So there is an irregularity. There is an irregularity in the sun's motion through the zodiac. So it might be moving, from our perspective, it may be moving faster when it's in Aries, for example, than when it is in Virgo. Sometimes it moves faster, a little bit faster, and sometimes slower. A little bit slower. Okay? And the question is, why? Why does it seem to speed up and slow down from our perspective, even as it's making its course through the zodiac over 365 and 1/4 days? And here he provides a couple of reasons why people had given for why the sun might exhibit this irregularity. So why would it do this? I'm going to explain a couple of reasons. The first reason that people had speculated is what was called an inconstancy, this is the term he uses, an inconstancy in motor virtue. I know that sounds like a funny term, but I'll explain what that means here. An inconstancy in motor virtue. What does he mean by motor virtue? Well, motor virtue, you can kind of think about this, you probably see the word motor in there, something that's able to move, and virtue is kind of a power or a strength. So whatever is causing the sun to move, whatever that might be, that would be its motor virtue, the power or strength that's giving it its motion. And so this is the power that moves this, you might say, the sphere on which the sun rides. The sphere on which the sun is riding, according to this view. So if the sun is moving fast at times and slow at times, that motor virtue must not be constant. There's an inconstancy in that motor virtue. And that inconstancy could be of two types. It could be either an intrinsic motor virtue, that is its own ability to move itself. So somehow something within that sphere itself has the power to speed itself up or slow itself down, or an extrinsic, that is something outside moving it, something outside of the sphere that is responsible for its motion. So if there is an inconstancy of the motor virtue or the power to move of the sphere on which the sun is riding around this zodiac once every year, then it could either be intrinsic, an inconstancy in its ability to move itself, or extrinsic, something outside of the sphere that's slowing it down and speeding it up. Now, what does Copernicus think about this theory? He says the mind shudders at this idea. It does not seem fitting, according to Copernicus and others, that this inanimate object, this sphere, would sort of change its mind, that in order to speed up and slow down, it would have to sort of be changing what it wants to do itself, and that seems to be implausible. Or on the contrary, if there's something outside of it, some extrinsic thing that's speeding it up or slowing it down, that also seems implausible. After all, if there's something extrinsic to it, it seems like in the best possible system, as he says, it would be moving at a constant rate. So he dismisses this idea that there's an inconstancy of motor virtue. He doesn't like this. What he does say, and this he says is the better idea, is that the sphere on which the sun is riding is not in fact centered directly on the Earth. The sphere on which the sun is riding, so to speak, is not centered on the Earth. This isn't Copernicus's idea, this is somebody else's idea, and someone else, their explanation of why the sun would appear to speed up and slow down. So how would this explain why the sun would appear from our perspective to speed up and slow down? Let me draw a little picture to explain this. So once again, if you put the Earth at the center right here, and you imagine, as the ancient thinkers did, that the sun is on a sphere riding around the Earth, the idea is you want it riding on a sphere that's rotating at a constant rate, okay? If it's going at a constant rate around the Earth, then from our perspective, it might go 1 degree every day as it moves around this celestial sphere. But then if this sphere is rotating at a constant rate, it should not appear from our perspective to speed up and slow down. It would just be moving at 1 degree every day throughout the year. Well, what about if you put the Earth instead not directly at the center of the celestial sphere, but a little bit off to the side? So it wouldn't be a homocentric sphere, it would be an eccentric sphere. So the sphere is a little bit off to the side. Okay, now what you'd have is you'd have this sphere rotating about a central point that the Earth is not located at. So this would be the center of the sphere, and this right here would be the Earth. So the Earth is not at the center of the celestial sphere. Well, now, according to this theory, you could have the sun going around like this, and the sphere rotating at a constant rate, and yet from the perspective of someone standing on the Earth, it would not be moving through the same number of degrees every day. Why is that? Well, you might think about, let's suppose in 1 month the sun moves that far around the circle. So from the perspective of someone on Earth, it goes from this angle to that angle. But then later on in the year, when the sun is closer to the Earth over 1 month, it's going to be going the same distance around. And so from the perspective of someone on Earth, it would go through that angle. And notice that this angle is going to be bigger than this angle. Because when you're closer to something, if it's moving at the same speed as before, it would seem to move faster. There'd be a larger angular velocity, one might say, as it's going around the Earth. But this is not by virtue of the sphere moving at a non-constant or circulating at a non-constant rate. Rather, it's because you're closer to it when it's moving past you on one side than on the other side. And in fact, this is an explanation for why the sun would appear to move faster sometimes and slower other times, while maintaining this idea of spheres rotating at constant rates.